fellow programmers. Welcome back once more to this course for drives. Okay, so we're going to continue off from our last topic, which was basically a drill, an exercise, which actually consists of entering the data plate information for the motor. We're not starting the motor. We're not connecting anything. It's only about entering data plate information. Okay? Now, the emulator or the simulator for Yaskawa is pretty complete. So I like it a little bit more even than the emulator or the Danfoss simulator. Aside from the fact that I also have a pretty big, like I'm very attached to the Yaskawa brand. Now, I gotta tell you guys, this brand was the opportunity when I had the chance to run my drills, my exercises, and my job as an automation engineer without being an engineer. So I was very young when I learned to configure drives. So I like this brand very much because it's pretty simple. So if you notice on your keyboard part, it is pretty easy. It has nothing to do with Danfoss. Now, as you may have noticed, when you run the drill, there are many functionalities or many functions, even though the keyboard concept is pretty simple. Okay? Now, we're going to start this off. Remember that this is only about entering the motor's data plate information. So what I want us is to get used to the most basic but important information, because if not, it's not going to work. So it's important that we know how to do this. So with this, we're going to learn how to do it with two types of drives. Everything that has to do with connection, startup, two-string or double-string or triple-string configuration, or the special parameters, we're going to look into this. So we're going to go step by step using this methodology, which, trust me, by the end, you're going to be drive experts. Okay, so we're going to start this off. Now, we're told that the drive is off. So to start it up, we need to power it on. Okay, this is what I love. It's very, very practical. Now, what can we see here? This, as such, is your main screen. Even though you see it very simple, it's your main screen. So I suppose that this is the frequency. And these digits are going to be the current frequency, okay? Now, our motor is not starting up right now, okay? So we're not even really going to pay attention to all of this. I want to focus only on the data plate, motor data plate information. Now, how are we going to enter this? First, we have to navigate with auto tuning, the parameter part, and they have many different functions. They have their current voltage, their current, the forward part, we can do it through here. But most of all, where are the parameters? We need to look for them in our menu or our files for parameters, which is here. Parameters, all of them. And I love this software because this actually tells us what each parameter is. So P is for parameters. This is for setup group parameters, which is something that was unable to be done. So we enter here. And now it tells us from A1 to 01 means that this is a level choice selection. Now, I could pretty well navigate with each one of them with all this data, okay? But we need to identify what group that I told you about. we need to identify the specific group to enter the motor type. What data would this be? I have no idea. Every brand is different, but they have the same logic. They should leave the same group for this. Okay? So it maybe took a while. Did it take a while to find this? Leave in the comments. And what did you, if you did find it, what did you base it on? So I'm going to leave you the advice, which is the king of all of this, for parameter configuration. So if I start guessing what parameter this is, I am never going to finish. Or it's going to take a very long time. So my recommendation is check to see what drive model you have, what brand, and then look for the manual. It is generally going to be inserted with your drive. You're going to get your box. It's going to be very pretty. And you're going to get your manual. I'm pretty sure you all already know this. And once you have the manual, you need to look for the group. Okay, this is why we're doing it step by step. But this one specifically is number one. Okay, so we need to enter our data plates for our motor. So more than the electronic connections, which we're going to look into further down, which is brake resistance, the cabling for the drive, etc. All of its protections, their electrical diagrams, how everything is connected, a little bit more specifically. Aside from that, once we have everything connected, we're going to power on our drive with our switch as this side here. Okay. And the first thing that we're going to do, what do you think it is? We're going to enter our motor data plate information, the one that we want to control. So remember, guys, that our drive has its potency. It's at a max, okay? So we can even control any type of motor which is within that same potency. So if our drive has, for example, I don't know, let's say 2 horsepower, or I don't know, 1.5 kilowatts, which remember, that's their equivalent, okay? But if it's 2 horsepower, my drive potency and my drive potency. So the motor needs to be 2 horsepower down. Can I control it? Yes, I can. Okay? I can control 2 HPs? Of course I can. Can I control 3 horsepower? I say no, not for my preference. Can it be done? It can be done if we tune it correctly. But is it right to do so? I do not recommend it. If your drive is 2 horsepower and then you say, oh, well, my boss actually was the one who told me that I need to control or I need to buy a 2.5 horsepower engine. I mean, it's only half a horsepower. Don't do this, guys, because I've seen many problems because of this. Drives can get overburned as well. Okay? If it's not going to last for, I don't know, 10 years, trust me, this is going to last you only for 1 year. Sometimes even weeks only. Okay? So make your capacity and your drivability within its course. Okay? Now, we're going to enter different data plates. So what's next now? So we need to look for the internet manual or get it in physical, which is what's here with your drive. So right now, any type of drive has its manual. So in this case, it's in Spanish. Okay. But we can also look for it in English. So what am I going to look for here on this side? So Control F. And we can even look for our motor. But I'm also getting 1,709 searches. So what we can do is we can look for parameters for motor, which are unavailable right now. Oh, well, actually, here they are. No, yeah, for the motor, yeah. So let's see here, guys. Let's look for, let's run a diagnosis. Okay, here we go. So here we need to be very smart about this so we can run a more efficient look. If you're going to be in the drives part, all manuals needs to be in the same place, but they have the same logic. So therefore, we need to be very, very smart about this and be basically some small detectives, which you're going to start noticing. You will notice once we see or look into different things. So this manual has 326 pages. How long are we going to find the same type of parameter so we can run a search on the motor type? It wasn't even 2 minutes. Now, how do I know that it's this? Because it's telling me motor data or motor trim. So we also need to be very smart in English. And generally, you also need to find kilowatts or look for potency, which in English is power. Look for amps or current, which is the data that is going to help us to enter this data plate. Now, with this, I know that this is the E1 parameter. Okay, so Yaskawa, what they wanted to do was they wanted to arrange their parameter type to enter in the E category. Now let's go here on this side so you guys can see the difference. It may be a bit obvious, but for all of you guys who know nothing about this, it must be heaven. So what is going to happen here? Motor information. Let's suppose that for the Rodrigo drives, I decided to name this group PC1, which is motor data plate information. But for Yaskawa, it's not going to be called P01, but it's going to be called E0. Oh, it's E1, sorry. E1, which is motor parameter. So I'm going to enter here. And here, this is E1, 01. So what does this match? This is my voltage. Okay. So input voltage configuration. Okay. So configuration for voltage for input. Do you see this? This is why I'm saying that everything looks alike. They're basically all the same, but their memory change. Or at least on how their memories are, what they're called. So if I want my motor plate data information for Yaskawa, it's going to be called memory E1, which are the groups. And then after this, they're going to be stored that way for my memories. Okay, so they're storing this way. So basically, having said this, how did you guys do it? Did you enter that data plate information? So we're going to go out to our E part, and here you go. So E1, enter. Now, what's going to happen with category E2? So for E2, we have our motor parameter, but it's telling us that they are within their part. But right now, this is a different category, but this is engine nominal. So motor current drive, and over here above, we have our voltage. Although this is voltage, this is current, and this is how the Japanese this Japanese company decided to do so. So everything that has here is for the motor part. So it would be like this, so that you get an idea. So it's not E1 here. This is E, okay? So within E, we are going to create here a new file, which is called E1, okay? So E1 voltage. And this voltage input is going to be within this file. And then we're going to have here a different file that is called E2. So current. Now here for voltage, we already added a parameter, which is 01. And now we need to create E103, and then afterwards E104, E105, etc., etc., etc. So because this is also combining their frequencies, so this is the current, and then in L3 it says control type characteristics, DF for motor number 2. So this we're going to look into for further down. So this is a different type of motor, not only Hector. Okay? And so on. So this is for pattern characteristics. This is the name, not the configuration. It's not a voltage. So Yaskawa is telling us that this is for characteristics for BF pattern. And here Yaskawa is telling us parameter, which is basically this. It's not the current. These are motor parameters. So if you can tell, this is exactly the same, but with motor number 2. What happens is they can control 2 motors if you wish to do so, which is not recommended, but you can do this. Whoever wants to do this, you can go ahead. You're free to do so. And then it goes to parameter number 5. And you guys can tell, actually, that these are memories for the same thing. So if you analyze the Danfoss manual, they're going to be very similar within your parameter. Okay? So what we really need to control this is basically the same thing. Okay, guys? So we have here our parameters for group E, for group number 1, and group E1 and E2 match motor number 1. So parameters for group E3 and E4 match to motor number 2, in case we have that option. However, our parameters E5 are for the PM motor. So what does PM mean? That means permanent magnets. So we have that other option. So it needs to be 1 motor, but not for any brand. It needs to be a specialized motor, which is Yaskawa. So if we need a permanent magnet information, but it's not Yaskawa, we're going to be in big trouble. Now, you may ask, well, what I want to do this for? So when we plan to use a PM motor, which means that we're going to need position. So this drive is going to be planned with motion or motion control. So this is going to be for a pretty simple characteristic, but it has this option. So just in case, if you ever need this. So we need to use only our permanent magnet motor, but it has to be Yaskawa brand. Okay. Now you may say, Rodrigo, we're ready to enter all the data. And I can tell you who selected these parameters. Whoever did so did the right thing. But maybe some of you were very observant in doing so. So I'm going to look for my document, for example, HP. Okay. Now here, we need to enter our potency, okay? Our motor potency. But there is a different type of parameters, a different group, which are called motor adjustment, and they are within the T category. Now, this is where we might get some confusion, because you may say, well, in the E group part, we can enter our motor plate data. But just as so, we can enter the information for our T group. So which one should I listen to? So let me tell you guys something. We need to listen to both of them. Okay? We need to enter our data only by using E1 and E2 groups. But we also need to enter our data information on the T group, so we can optimize it even better, okay, for our process, for its motor process, okay? It would work if we didn't enter our T data. It will, but it's going to work even better if we, on this side, we enter it, okay? So Yaskawa has a particularity, which is called auto adjustment, which is like an artificial intelligence that is going to learn as we start doing and running more processes, okay, which is something incredible that Yaskawa has. Okay, so because they, with their artificial intelligence or with their drive, as time goes by, they optimize their electric energy. Okay, they start optimizing their motor potency. Okay, so this is for us to optimize our motor data even better. Now, it works with our E1 and E2 groups, and they work excellently if also we enter our T group for that data. Do all these brands have this? No, they don't. I only know very few brands. Within these, they are Yaskawa. But unfortunately, our emulator or simulator is not like that, doesn't work this way. So it doesn't have that characteristic, or as far as I can remember, they don't have it. They don't have that T group parameter because physically they have nowhere to be turned on from. Okay? So we're going to look for the parameter control part. Which are these? So we're going to look for our T group. Okay, so here we have our parameters, and we are going to be able to enter them, which you probably already did. So E1, and then it says that E101 is to enter our voltage. Okay, so it's this one, which is non-modifiable. Apparently, because that drive already has that voltage. So this is the inverter voltage, or the drive voltage. Also, the drive is called different ways, in different ways. It's drive in English. In Spanish, it's called frequency variator or speed variator, which both ways are correct in Spanish. And it's also called an inverter. You probably already know why it's called that, and it's because of the internal part on how it works. Okay? So any one of the four names that I'm telling you about, that I'm saying, they are correct. Okay? Now, let's look for our parameter group T. This is N, this is O, and it repeats again. So in the emulated part, there is no T part. However, if you don't have your physical part, then I recommend you do it both ways. Okay? So then, going back here we go. We do this, we do that. Something that also for data plate, guys, then what data is the one that we're going to input? It's actually this. We're going to enter here, for example, for this data plate. Okay? So we're going to go back. We're going to head to our emulator. And we're going to select our parameter part. Here we go. So we're going to look for our category or our E group, which is E1. And it's telling me E101. Okay? Now this voltage is for our inverter. Okay? So therefore, it's already been predefined. Probably if I try to modify this, it's going to give me a mistake. It's going to give me an error when we enter our information. So this is only for our drive. What the drive has, we're unable to modify as voltage. So then here it's telling me our VF pattern. What does VF mean? It's a control type, which means volts per hertz, or volt frequency. And then there's a different type of control, which is OLV, which is open loop, which is an open one. Okay? So it's an open loop vector. Now we're going to look further in the future. We're going to see where this is used. And then our PM part, which is our permanent magnet part. So this was taken by Yaskawa, and these type of controls are basically implemented through all of our drives. Okay? Although Yaskawa implemented through its own brand, its PM brand or permanent magnet brand. That's what they have additional. And here it's telling us these parameters can only be used unless, this is the personalized part, which we select for our O option or the volt per hertz option. So we're not going to select anything here. We are not going to modify this. And here it's telling us, well, what's the nominal speed for our motor? Well, it says so right here, to configure the data plate on both amps. So therefore, we're going to verify this. So nominal converter current for E201. Here we have our amps, and we're going to enter the information here. So if I want to select 50 hertz, I select this, and then, well, then I select, yes, let's make it 400 volts. Now, It actually needs to be 230 volts. So let's select this. Make it 50 hertz. So 230 volts and 4.4 amps. So we're going to do it as such so that we don't get confused. Okay, make it 4, go to the right. And here we decrease this by 4.4. So this is nominal current. And our data is stored. And then what is our manual telling us to do? So this is the drive average. We don't have this data. So this is the data current, which we don't have. So these are parameters. And as you can see, these are additional parameters, which the more we fill, the motor is going to be more optimal. So we generally don't have this data. Okay, so pole numbers, that should be 4. Here we go. So motor resistance from line to line, we don't have this. Indulgence. The torque compensation, we don't have this. And here, this is important. Okay. So this is the kilowatt part. From 0 to 170. So let's suppose that this is an HP. And actually, that's going to be 11. So I want an HP. And here it's telling me our formula, which is direct. Which is, where does this match? 476 kilowatts. So therefore, go here on this side. So this is 740. Let's see if this is correct. So from range 0 to 650. So by default is 0.74 kilowatts. Okay. And what else do we have here? Well, this is in repeat. This is in loop. So you guys are going to tell me here, well, what's going to happen with our voltage here? Our voltage is set by default with the same information that we have, that we already uploaded, which is the same thing for our drive. Okay, same thing. So if I want the specific voltage, what I recommend you guys to do is that you enter physically, and here we go. So here for this part, for our parameters, for our motor adjustment, it's going to allow us to enter our nominal voltage for our motor. Remember that I told you that this is the optimization, the additional optimization for that motor. This is where we're going to be able to enter it. And only for what our drive is going to allow us to do so. Because if you say, well, you bought a 255 volt drive, so what's going to happen here? Well, we would be unable to change it to 400. We need to be very careful with this. So whenever you guys ask for our motor, you need to decide what voltage is going to be used. So quite the contrary, if you're not careful with this and you don't select the voltage for our motor, if you created it with a delta connection and then you said, well, I think it would be better with a bigger voltage with 440, or maybe I should use a star connector or a star connection. The only problem here is if the drive that you asked for is at 220 volts, then it's going to be a big issue. It's going to be burnt out. So this is not going to work with my motor. So you need to be very careful with this data. And if you're going to select 440, you need to select a 440 drive. So basically with this, we have all the data and we have finished our exercise. How did you guys organize this? What did you learn from this video? And what did you learn from you guys doing it for yourselves? Was this complicated? What was easier for you? Danfoss or Yaskawa? So tell me your comments and then tell me what the data input is for your motor within these emulators or simulators. And now we're going to go to our next topic, and I'll see you guys in our next class. Big hug, guys.